Hello, welcome to the first Formula Hybrid SolidWorks tutorial. Today we're going to be going over some of the basics of SolidWorks, and through that process we're going to be making a small model cannon of the same type that you would make in the RPI Processes course. You'll notice here I've started up SolidWorks, and the current version I'm using is SolidWorks 2014. This isn't essential for this tutorial. If you have an older version, that will work fine too. You just have to be aware that some of the icons and some of the interface may have slightly changed between versions. So you may have to hunt through the menus a little bit or use Google to identify where different things are. So to get started here, we are going to go to File, New. And you'll notice that we're prompted with three options here. We have Part, which is what we're going to be doing most of the time. We also have Assembly and Drawing. So pretty much anything you do in SolidWorks will be made up of one of these three things. So to start out with, a part is essentially the smallest component that you would use in your model. So it could go down to a nuts and bolts component level, or if you were designing something with less granularity, it could represent a larger object. But essentially, the smallest part in which you would want to accurately model should become a part in SolidWorks. Next up, we have the assemblies. The assemblies will typically take parts and constrain them together through the use of things called mates. Mates can be done in many different ways, but essentially the assembly will take your parts and it will allow you to make an entire structure with them. So it's extremely useful. You can also use sub-assemblies inside your assemblies, which is especially useful if you're making very large assemblies, which is what we do with our master assembly with the car, because it allows the program to run slightly faster. And last but not least, we have drawings. So SolidWorks 2D drawings are what you would expect. It's a 2D engineering drawing, typically of a part or assembly. So one of the two things we created up here. And generally a drawing will be the last step, and it's also sometimes optional. It's usually depending on if you're intending to get this part machined or if someone else is going to be making the part. You'll also note over here on the side that we have the tutorials button. This is highly recommended. The SolidWorks tutorials are very good if there's any feature you want to understand or if there's something that was unclear. So I'd highly recommend taking a look at these if you're confused. So to get started here, we're going to begin with a part. We'll click that, click OK. And now you'll notice that a new interface is opened. This is the part interface. Some of the important things to note here are this is the general screen. This is where we'll be interacting with our part and where we'll be navigating with it in 3D. Up here along the top we have our toolbars as we've seen before. Not much has changed here. You'll note this is the file name. Currently this is just default part 3. A couple important things to look at here are the different tabs you see along the top. You may not be seeing a number of these, and that's alright, but for the moment the most important three for us are going to be the Features tab, the Sketch tab, and the Evaluate tab. So starting from the Sketch tab, this is where we're going to begin most of our parts. Generally, we will design our parts in a 2D sketch, and then through various methods we'll turn that into a 3D part. You'll notice that we can create sketches, we can use dimensions and basic shapes to generate whatever kind of illustration we need to make our 3D part. And there's also some useful tools over here on the right that we'll cover in a moment. Under the Features tab, this is essentially what we use to either modify a 3D object or turn a 2D sketch into a 3D object. So you'll notice here are some tools for transforming a 2D sketch into a 3D object, and there's also some more advanced tools that we'll probably touch on a little more later. The last tab that we should look at right now is the Evaluate tab. This includes certain tools such as Measure, which allows us to actively measure between different parts of our part, which is very useful. We'll also see such things as mass properties, which we'll go into more detail later, and there's a couple other useful tools here that you may find necessary throughout the process. So to get started, we're going to go to Sketch, and we are going to create a new sketch. You'll notice there's a drop-down tab on many of these different icons, which allows for the selection of variations on that. In this case, we'll just be doing a typical 2D sketch instead of a 3D sketch, so we can do that just by clicking the button here. And you'll note that we're immediately prompted with a plane on which we are going to draw our 2D sketch. So by default, SolidWorks will create a coordinate system and a origin and planes for your part. You can see here it started out with the front plane, the top plane, and the right plane, and at the intersection point of all these planes is our origin, which is not shown right now. So for the purposes of making our cannon, we're going to start out by clicking on the front plane. You'll see it highlights here when I hover over it. I'll click on that, and now we're normal to this plane. So we are prepared to begin sketching the first part of our cannon. Something else that's worth pointing out at this point is the thing over here. So this is the Feature Manager Design Tree. It's extremely useful, and it's what makes SolidWorks especially powerful as a parametric modeler. So you'll note here that we have our part name, we have a couple other interesting things. We can look at history, sensors, annotations. These aren't really critical, so we won't be looking at these three in the tutorials right now. You'll also notice that we have something such as material. This both affects the visuals of the part we're working on as well as material characteristics, densities, things like that, so we'll touch on that a little bit later. You can also see the three planes for our part are illustrated over here, and the front plane has been highlighted because that's what we're currently working on. And last but not least, we see the origin here. So for the moment, this is not very filled out. As we continue to work on the part, you'll notice that every feature we make, every sketch we produce, and every extrusion or cut that we make will show up here as a feature in the feature tree. And this is what allows us to go back and make modular SolidWorks designs. So if we were to design a part and we determine later on that we need to change its critical dimensions, we can change something earlier on in the chain, and then everything will propagate downward through the tree and update our final part. So if that's not clear right now, that's alright. We'll be going over it a little more later. But for the moment, let's start out drawing our first part. So to begin here, we're going to go up and we are going to select the corner rectangle command. We'll click on that. And now, moving over here, you'll see there's a little icon that shows that we are opened the rectangle command, and we'll click one point at the origin. We'll then drag and click once again to set the other point of the rectangle. So at this point we're drawing a side view of what's going to become the cannon base. And the first thing we need to do is put down some critical dimensions for how we want this to, how much space we want it to take up essentially. So we can go up here, we can select Smart Dimension. This will automatically choose whatever dimension is most appropriate for what we're trying to dimension. As with other tools here, you'll see that there's a drop-down menu. We can choose some specific ones if we choose to, but for the moment we're just going to stick with a standard Smart Dimension. So the first thing we want to do is we want to set the width of our part here, and we can do that just by clicking on the line. It'll automatically assume we want to select the entire thing, and then we can come down, position the dimension exactly as we want it to be, click once again, and then the modify window will open up, and this is what allows us to select what we want this dimension to be. So you notice the dimension has a name right here. Typically we'll keep these by default, and it also has the value. So for this case we'll type in 2.5 inches. You'll note by default I'm running the inches measurement units. If you need to change this, down here, slightly out of view of the window probably, but if you go down here you'll see a unit system selection, and you can set your defaults for whatever unit system is most convenient. For most of the things that we do on the team, we'll be using the IPS unit system, which is essentially Imperial, because it's most convenient to get those parts so in terms of suppliers and things like that. So the next thing we're going to do is we're going to set the height of this rectangle. So we'll click here, and we're going to set this to 1.5. It's also worth noting that when we are making dimensions, we can also dimension between points. So for instance, I could have clicked this individual point and this individual point down here and set that dimension. But for the moment this is fine. So the next thing we're going to do is we are going to go up here and select lines. And what we're going to do is we're going to make essentially a staircase pattern. We're looking at the side of the cannon base right now, and this is going to be cut into it, which would be realistic of a naval cannon of that era. So I'm going to go in and I'm going to do a really messy job of drawing in how this staircase is supposed to look, and then we'll use some tools to go in and fix that up. So I'm going to click here, I'm going to click another point, I'm going to press escape. This exits me out of the line dialog. I'm going to make a new one up here, over a little bit, one more up, over once more, and up. So you may have noticed a couple things were appearing as I was drawing this really bad staircase. First of all, you can see these. This little square here is essentially representing a relation that the line is automatically snapped to. So when I drew my line, and I'll do it again here just to show, there's a couple different options that it will automatically try to snap to make your job easier as you're drawing your part. So here, as I move it close to vertical, it will snap to vertical, and we'll see that little yellow vertical constraint or relation popping up. So it's a useful thing to keep in mind as you're sketching your parts. So now for making this staircase a little bit better, there's a couple things we can do. The first thing is, you'll note right here, I have overlapping lines. I don't want these. These are essentially excess that isn't supposed to be there. So a very useful tool that you're using in your 2D sketches that can help you eliminate this is something called Trim Entities. So I'll go up here and I'll click Trim Entities, and I'll essentially just click the mouse button, hold it down, and drag it through the excess, and you'll see that it will delete the things that I don't want. This can also be used to extend lines and things like that, but we will go over that a little bit later. Great. so now we've gotten rid of the excess lines over here. Now what we need to do is make this line horizontal. This is already vertical. Make this one horizontal. Essentially make it like any normal staircase that you would utilize. So for the purposes of this, we're going to introduce a new way of constraining parts, and that's going to be through the use of relations. So if you go up here, you'll see there's a little button called Display/Delete Relations, and if you click the down arrow, you have the option to add a relation. You'll also note that in my version of Solidworks, I've customized it so that add relation is right here on the toolbar, and I'd recommend you take the time to go do the same because it's a very useful command and we'll be using it quite a bit. So I've opened up the add relations. We see that they have the new interface here for adding relations, and all we have to do is simply click on the line segment we want to add the relation to, and in this case we're going to add a relation to set it parallel to the horizontal. So I'll click this button and we'll see this is now horizontal. Great. And I notice this is a little bit high. It's making it hard to see what I'm doing, so I can just click on any part at any time and drag it down. You'll note at the same time, if I try to click on something that's in the black color, it doesn't allow me to move it around, and this is because this part has been fully constrained. So over here in the blue, there's no dimensions on this line segment. I can pull it around as much as I want. There's nothing keeping me from doing so. If I were to go in and I were to add a dimension using the Smart Dimension tool up here, I could click on it. I could set this to 1/2 inch, for instance. And now this line segment here has gone black because the distance between here and here has now been set, and I can't freely move it around anymore. So I'll go in and quickly add relations and dimensions to the rest of these, and you can follow along if you choose. So the next one will be 1/2 inch here. Nope. Excuse me, 1/4 inch here. Another useful thing is if you need to go in and edit a dimension like I did right there, you can simply double click on it. That will reopen the dialog that we had there earlier so you can edit it. I'll go in and I'll add another relation to make this vertical. I'll go in and make this horizontal. You notice with lines, you actually don't even necessarily need to be in the relations dialog to add a relation. It automatically assumes when you're clicking on lines there's a limited number of constraints you might want to add to that. And you can see after I've clicked on it, I have the option to make it horizontal or make it vertical here, as well as over here in the lines property window. So I'll make this one horizontal. Good. So now we have all our lines vertical and horizontal as necessary. I'll continue to go in and add a couple more dimensions. Great. So now everything's the way we want it to be. There's only one more change we need to make before we turn this into a 3D part, and that will be eliminating these sections of lines. So essentially we want this material to be removed here, and in order to extrude something we need it to be in a closed loop so that Solidworks knows what part you're trying to extrude into 3D. So again, we'll use the Trim Entities tool. I'll click on that here, click down, and then drag through the segments I no longer want or need. So something interesting happened there, and you may have noted that the top of each of these steps turned blue. This is because the constraint that we previously had, which set the entire height of the cannon base, was deleted when I eliminated that line segment. If I go in here again, I can reconstrain this by setting a new dimension, and in this case I'll click between the 2 points here. There we go, reset it to 1.5, and everything's fully constrained again. So, before we turn this into a 3D part, we need to do one more thing, and that is check that everything is fully defined. You can do this by ensuring that everything is black in color, or if you go down to the bottom here, and this won't be visible to you at the moment, but there is a fully defined thing right below my cursor right now that will either show fully defined, underdefined, or overdefined. Might be over-constrained in this version of Solidworks, I'm not exactly sure. And in this case, we always want to make sure that everything is fully defined. So, assuming we've gotten that done, we have a couple options for how we can exit out of this sketch. We can either go right over here to this pencil with the reversed arrow. We can click on this. This would remove us from the sketch. We also have the button up here which has been depressed since we clicked it, which is the Exit Sketch button. However, the other thing we can do, and SolidWorks is fairly flexible about this with most features, is we can go directly into the next function we want, which in this case will be turning this into 3D without exiting the sketch. And in order to do this, we'll just go and click on our Features tab here. And you'll see that we now have the option for Extruded Boss Base and Revolved Boss Base. Because we are essentially emulating milling operations and the making of this cannon base if we were to be physically making this, we would do this on a machine tool such as a mill. We'll use the Extruded Boss Base option. So I'll click on this, and now you'll see that we've rotated to an isometric view, and by clicking and holding on this arrow, you can see how this part, there's a little preview of how it would be represented in 3D. So for the purposes of this cannon base, we're going to choose to make this 1.5 inches, and you can see, as with all the other commands, the Boss Extrude command gives us the option to set the distance. I'll type in 1.5. It'll automatically presume inches because I'm in that unit system, and I'll click Tab there to adjust the preview. So, by clicking the middle mouse button, we can begin to look at things in 3D. So you can see now I can rotate around, I can verify that this is how I want, and then if I'm happy with it, I can go and I can click on the green check here. There's a couple other options here for the Boss Extrude. You can note that we can choose what we want to extrude from. In this case, we'll probably keep it at sketch plane. It's fairly typical. We can also choose how far we want to extrude. Currently we have the blind extrusion, which means it will blindly follow the length input that we put in here. However, we could also have different things, such as if we had a more complex part, we could go up to the vertex of another point of the part, we could go up to a surface, offset from a surface, up to body, and midplane, which essentially extrudes in two directions at once. So for this case, we'll keep this blind, and we'll look through some of these other options a little bit later. We'll click the green check mark. Great, so SolidWorks has now rendered our part in 3D. A useful key command if you lose track of where you are in the part is you can double click the middle mouse button, and that will always bring you right back to home. At this point, it's worth going over some of the ways that we can navigate around a 3D object. So by clicking, we can select any face of this. This is fairly much what you would expect. As I talked about earlier, you can also hold down the middle mouse button and rotate around. If you don't have a mouse with you at the moment, then you can also use the arrow keys on your keyboard, which will allow you to navigate in the same type of way. You can also zoom in SolidWorks, and this may be slightly counterintuitive depending on what CAD softwares you've used previously, but typically rolling your finger forward will move you back from the part, and pulling the mouse wheel towards you will move you back towards it. This can be changed in settings, but because it's fairly typical, I'd recommend getting used to it. You'll note there's also a couple ways that we can navigate around this in direct views. So by clicking on this icon up here, you'll see in my version of SolidWorks it's given me the option to select any one of these planes to look normal from. So in this case we could have perhaps a trimetric view, or we could select a front, back, side view. You can also select one of these up here in the little window that pops down. So in this case I'm going to stick with the view I had before. One that's worth noting is the normal view. So if I were to be clicked onto a plane, or if I were to select a sketch and I wanted to go normal to that plane in order to work on that 2D sketch, I could click this button, which is going to be very useful. But for the purposes of this, I'll keep myself in a roughly trimetric view. So if we go back over here to the Feature Manager design tree, you'll see where our sketch used to be, we now have a Boss Extrude. And this is because the Boss Extrude operation that we performed on our 2D sketch has now become the parent of the 2D sketch. So if I go over here and I click on the little plus mark, you'll see it opens up, and the sketch 1 is now the child of the Boss Extrude operation. You can see it's highlighted around here on the outside that we extruded from. And this will continue to develop as we work on this part more. So the next step is to make some holes in the cannon base. This is what will allow wheels to go onto the cannon base as well as allow the cannon barrel to pivot. So for making our next sketch, we're going to go back to the Sketch tab. We are going to select a new 2D sketch. And now, instead of drawing on one of the key reference planes of the part, we are going to actually sketch directly onto the side of the part. So we are in our 2D sketch dialog. I can now select, click on this face, and we're now sketching directly onto this face. So now we want to use one of the commands we looked over earlier because we want to be normal to this plane in order to sketch on it in a way that we can clearly see. So I'll go up here. First I'll click on this face. I'll go up to this View Orientation button, and I will choose to go normal to this face. Great, so right now we're looking exactly at where we want our 2D sketch to be, and we can begin sketching some of the holes. So, in order to sketch holes, it's fairly obvious. We'll go up and we'll use the circle command here. Something I usually like to recommend when we're making 2D sketches in SolidWorks is to start out by drawing roughly what you want your piece to look like, and then go in and add relations and dimensions to bring those things exactly into spec for what you want. So I wouldn't waste time trying to click precisely and get every line exactly where you want it, because it's fairly easy to go back in later and either use the trim entities tool to cut off lines that are excess, or relationships or dimensions to bring things into the right distances. So first thing we're going to do is we're going to add a circle up here. I'll add one more down here. You'll notice as I bring it over here, it tries to go in line with the bottom, which is fine. We'll add a relationship to make sure these two stay concentric in a vertical line with each other later on, or excuse me, coincident in a vertical line. And then I'll add one more circle over here. Great. So as I said earlier, let's add that relationship right now. I'm going to go to the display, delete relations, and add a relation. I'll then go in and I'll click the center of these two circles. And you see we now have a couple new options for what we want to do with these. We could fix them, we could merge them, or we can add a vertical or horizontal relation, kind of similar to the lines. So in this case, we want these two to remain vertically in line with one another, so we'll select the vertical option. And you'll see we now have the little icon pop up on each of these that shows they're in line. You also note that you can now click on them and you can pull them around and they'll stay in line with each other, which is nice. You may note that if you're working on a very complicated sketch that some of these icons start to clutter up and get in the way of things. And if that becomes an issue that's problematic, you can use this command up here. So you see the small pair of eyeglasses up here. If you click on the down arrow here, there's a number of different icons. One of these icons is the View Sketch Relations icon, and if I were to click this, those will disappear. I recommend, especially when you're getting started and even later on, that you keep the sketch relations on so that you can see if something's breaking or if you're over or under constrained. Perhaps it's a relation that's getting in the way, or maybe you need to add more relations. So I like to keep them here for the purposes of clarity. So for the next step, we are going to want to do something special with these two holes. So I'm going to start out by using something called a reference line or a construction line. In Solidworks, I like to call them center lines, and I will select this by selecting the down arrow next to the line command here. Go down to center line. So this is similar to the lines we did earlier, except a center line is special in that, first of all, it's dotted, and second of all, it's not something that will extrude when we try to turn this into a 3D part. So we don't have to worry about this being part of our closed loop shape in order for it to extrude. So what I'm going to go do here is going to click the center of each of these two. You'll see this turns orange when I reach the center point to show that it is coincident to that point. And I'll click the center point over here and click escape to escape out of that dialog. Now our two lower circles are linked to each other. So the first thing I'm going to do is I'm going to click on this construction line and I'm going to use a relation to set it horizontal. So now these two are set relationally horizontal to each other, just as these two are vertical. Except in this case we use the construction line to make them horizontal with each other, and this is for a specific reason. So I'm going to go in and I'm going to make a new relation, or a new dimension, except with this dimension I'm going to use it to dimension the line between these two circles. And I'm going to make this exactly 1.5. Click escape to exit out of that dialog. And now what I want to do is I want the center point of this line to be centered at the bottom of the base of this. And this is another case where we can use relations to solve the job. We could also use dimensions and go between here and the center point of this line. However, there are disadvantages to this in that if we were to later go in and change the base width of this part, that wouldn't update necessarily. If we were to make this 0.75 across, which would be halfway, then if we were to make this entire thing 3 inches wide, that wouldn't update accordingly to be in the center. So by using a relation, we can make our model more future-proof. So I'm going to go up to the display, delete relations, select the down arrow, add a relation, and now what I'm going to do is instead of just clicking on the line segment or on a circle as we did previously, I'm actually going to use the right mouse button to click on as close as I can get to the bottom of this part. You'll notice it's now selected the bottom line here, and I'm going to go down in this box and click on select midpoint. So now we have a midpoint of this segment selected. I'm going to then go up and do the same on the construction line here. I'm going to right click, going to select midpoint, and now we have these 2 points. So now what we can do is we can go in and we can make these two vertically coincident with each other. And now, you'll note, this is locked in place. If we were to change the base size of this, it would automatically update, so the center between these two circles would be centered at the base. You'll note everything here is still blue, and that's because we have not fully constrained everything yet. So let's go in and do some of that. For the diameters of each of these circles, we're going to make them 1/4 inch, so I will use the dimension for that. This is a case where a smart dimension will realize that we're not trying to dimension between two parts or dimension the length of a line, and that we're in fact dimensioning the diameter of the circle. So I'll click on the outside of the circle. You can see I can move it around. It will show in different, it'll illustrate the dimension in different ways depending on where it is. It doesn't really matter. I'll click again and I will set its diameter to 1/4 inch, 0.25. I'll then go in here and do this with the other ones. And I'll take this last one as for a moment to illustrate some of the power of Solidworks when it comes to setting your dimensions. So I've clicked this, I'll set this here, and let's say for the sake of argument I didn't know what 1/4 inch was in decimal. Well, that's actually fine. I can go in and I can go 1/4. And Solidworks will automatically interpret this and determine what it is in decimal form. If I had something more complicated, or if I had an equation, I can even go 1 plus 0.25 over 0.97, for instance. It's fairly messy, and Solidworks will automatically interpret that as well. So it's very useful. It's nice not to have to know all of your fraction to decimal conversions in your head necessarily. And it's especially useful if you are trying to add together a number of dimensions and you don't want to bring out your calculator every time. You can essentially use Solidworks as a calculator for most purposes. You can in fact even do more complex equations such as your basic trigonometric functions and some other cool stuff that we may cover in later videos if we have time. So I'm going to set this to 1/4 inch for now. And now there should be only 2 more dimensions we have to add to this before everything's constrained. First off, we have to set the base up a certain height. And in this case, let's go with 1/4 inch because we're remaining pretty consistent. And last but not least, we have to choose between the center of this circle and the top here, how low we want it to be down from the top, and we'll also make this 1/4 inch. Great. So you'll note that everything is now constrained, everything is black in color, so we know we are ready to extrude these circles out of our 3D part if we so choose. However, before we go and do that, I'm going to add in one more thing, and that is going to be to select another center line and draw it between about this point and this point. Now this isn't going to make a lot of sense at the moment, but if you bear with me, you'll see how this is going to become useful in the next step that we're working on. So for the moment, let's set these dimensions to, how about 0.75 here? Maybe 0.8. And over here, we will set it to 0.5. Great, that looks good. So, as we said earlier, the construction line, we don't have to worry about either of these 2 construction lines extruding in this process because it's not going to interpret them as part of the shape. And if we do a quick check here, we'll see that all of our full lines are in closed loops, so Solidworks should interpret that properly. So if we now go over to our Features tab, we can select Extrude Cut, which has become available to us. This is essentially the same command as the Extrude boss base, except it removes material instead of adding it. So if we click on this, and if we click our center mouse button and rotate around, we'll now see that we are cutting in 3D. And for these purposes, we can either continue to use blind, or we could use something such as through all. And through all is a relatively nice command. It will essentially cut your part through anything that's a previous feature. So in this case, the previous feature was our extruded base. If we were to go and change our base and we had this set to through all, so say the base became 2 inches thick instead of 1.5, this would automatically update to cut all the way through that because it's going to go through everything. However, if we were to make more features after this, we wouldn't have to worry about this continuing to extrude through those because it only acts on things above it in the feature tree. So we set this through all. We're going to click the check. Perfect. So we now have our holes cut through our cannon base. And if we look over here on our feature tree, we can see that we have our boss extrude and we have our cut extrude, each one with the child inside it. And one thing we're going to do now is you'll note that each of the sketches we've been making has been turning invisible after we've done our 3D operation. One of the things that we can do is we can go in and, for instance, I'll open up Cut Extrude. I will click on the sketch here with the left mouse button a single time, and we have a couple options we can use. So we can either roll back, which will move this bar back, and this bar essentially determines at what state the model is in. So if you were to develop a full model with many features, you could drag this bar back and it would bring it back to whatever state it was at that point in time. You'll also see there's a couple other options such as zooming normal to the sketch, zooming to the selection, showing your sketch, which we'll click right now, as well as going in and editing the sketch, editing the plane, and suppressing the sketch, which essentially turns it off. So in this case, we want to turn the sketch on, and we'll see why in a little bit here. So you'll note we're not in the sketch right now. The reason that it's not grayed out as this one is because it's visible, but we're not actually editing it. We're in our 3D interface at the moment. So for the next step in making the cannon base, we're going to create a third 2D sketch. And we'll go back into the sketch tab as you would expect. We'll select 2D sketch. We're going to rotate around our part, and we're going to make our next sketch on this face. So I've clicked this. I'm going to go normal to the sketch we just made. Great. So now we're sketching on this face. So in this one, we're going to be using the rectangle tool again. We're going to draw a rectangle roughly this size and location. And we're going to set some of its dimensions using the Smart Dimension command over here. So we're going to make it a 1 by 1. Great. And we need to choose a couple more things here before it will be finished. So we're going to go in and we're going to add a relation. Again, we're going to use the midpoint trick that we used earlier by right-clicking on this, select midpoint, right-click on the base below it, select the midpoint again, make these two vertically coincident. Great. Now our soon-to-be cut-out section is centered on the block. The last thing we have to do is set how high we want this square to come up or down. And we can just use a simple dimension for that. We could also, if we wanted to put it exactly halfway, we could use a relation between the center point of this and this. But for now, let's just use a dimension so we can change it more easily later. And let's make this 1/2 inch for now. I'll take it back. Let's make it 0.375 of an inch. Great. Okay. So whereas before we've always gone directly to features, for the sake of illustrating it, let's just exit the sketch at this point. And let's go back around and look at this in 3D so we can see where our 2D sketch that we've just made is in relation to everything else. And now we're going to be extruding cutting this. So we're going to go back to the Features tab. If I unclick the sketch, no problem, I can click on it again, and then I can click the command, which in this case will be Extrude Cut. I could also click Extrude Cut, and then select the sketch that I want to extrude cut. Works either way. It's one of the nice flexibilities of Solidworks. So the difference with this Extrude Cut is, whereas previously we've always extruded or extrude cut normal to the plane on which we've sketched our 2D sketch, in this case we actually want to extrude a channel out of the cannon base in which the cannon barrel will sit. In this case, we can go and we can click on this box over here, which is the direction of extrusion. The default is normal to profile. However, by clicking this box and then selecting the construction line we made in the last sketch, we've set a new direction. And we can see now that when it extrudes, it's going to cut along this vector. So we'll go in and we will change the parameters for how far it will go and select through all again. It will now continue all the way through our block. And click the check. Very good. We've now finished the basics of our cannon base. And if for the purposes of neatness we can hide the sketch that we've made visible over here, we can either click on it and we can hide it here, or we can go back into our feature tree, which now features all 3 of our features, and select the second cut extrude. Click the sketch once with the left mouse button and then click once again to hide it. And there we have our finished part. At this point it would be a good idea to save. And I'll just simply save this as cannon base. You'll note we're saving it to a part, and you can choose to save this to whatever directory is most convenient. If you don't have a Solidworks folder set up, I would recommend making one, especially on the Formula Hybrid team. I'd recommend making a PDM folder, which will later hold models that you get from the server, which we'll go over probably next lesson. So I'll go ahead and I'll click Save here. And it failed to save document for reasons I don't totally understand, but that's okay right now. At the moment we don't need to save it. So one more thing we can do before we move on to the next part is we can go in and we can add some material properties to this. So I'm going to go up here and I'm going to use the right mouse button to click on the Part 3. And you'll see we have a couple new options here. We have a number of things we won't go over at the moment, but at the bottom of that, above this divider line, we have the material option. And in this case, we are going to select a material to make this out of. So typically, these cannon bases are made out of aluminum. You'll see one of the default options for me is the 6061 alloy aluminum, which is a very common aluminum alloy many things are made out of. If this isn't a default for you, you can select anything else, or we can go into Edit Material, and we can take a look at the materials library in Solidworks. So Solidworks comes with a very expansive materials library, and these materials do much more than just change the color of your part. They change the density of it, they change every kind of characteristic you would expect associated with that material. And you can even define custom materials, which can be very useful. For the purposes of this, we'll stick with our aluminum alloy. I'll open up the aluminum alloy folder here, and I will go down to the different 6061 options. You'll see there's a number of different heat treatment options here. For this purposes of this tutorial, we'll just go with the generic alloy. Click Apply and Close. And now we have essentially virtually made this out of aluminum material. This gives us a chance to go in and look in the Evaluate tab, where a couple options have now become available to us. We can, as we said earlier, measure things. Measurements are fairly self-explanatory. You can measure between points, for instance here and here, and it will give us the direct distance between those 2 points as well as distances along our different axes. We can also go in and we can select normal faces, so I can select this face and then select this face over here, and you'll see obviously we have a 1.5 inch distance between those two. One of the cooler features is we can go in and we can select mass properties. And this will do more than just show the mass, it will also show the center of gravity of our part. So you can see here this custom unit system, LZ, LX, and LY, is showing us the center of gravity of the part that we've just designed. This is extremely useful, especially in suspension calculations and things similar to that. We can also look at the generic density of our part, which in this case our generic 6061 alloy is 0.1 pounds per cubic inch. We can also see how much this will weigh. It will be 0.31 pounds. We can also see things such as volume. This is extremely important, especially if you plan on 3D printing your part. You're going to be charged directly based on how much volume your part takes up, so you're going to be very interested in this number. And there's a couple other cool things we can look at. We won't go into them at the moment, but they're very useful. If for some reason you are working with a part and you need to define your own coordinate system, it's possible to do that. You can change the coordinate system here. In this case, I haven't set up another coordinate system, but it's possible to do in the Tools tab. We can also override mass properties. This is useful if you're essentially abstracting components such as an electric motor or something like that. It allows you to go in and reset the properties to exactly how heavy it is without actually modeling every single component inside. So very useful. Won't use it at the moment though.